Hello everyone, my name is Ignacio Mendizabal, and in this video I'm going to do a demonstration of my assignment for week 5 of CS50ai. So first I'm going to run my code and then explain the basic concepts. So now the code is running. I'm going to explain what was the idea of this project. So we have to implement a neural network that should be able to, given a set of images from road signs, it should be able to classify each image into one type of road signs. For example, if I give an image of a stop sign, then the neural network should be able to tell that that image corresponds to one stop sign. So in order to do that, we have to implement two functions. The first function was a load data. Basically, this function returned a tuple of images and labels. Each of these elements was a list, and basically what this function did was read all images inside a given folder and return them as a table. This was the first function that we had to implement, and it had to be platform independent, and because of that I used the OS separator. And then we have the get model. This function had to return a sequential model that corresponds to the neural network that we had to implement. So the first layer is a convolutional layer of 32 filters with kernels of 5x5. Then another convolutional layer of 20 filters and 3x3 kernels. Then I use max pooling with a pool size of 3x3. Next, I used once again a convolutional layer of 20 filters and 3x3 kernels. And then I use flatten to convert all that information into one-dimensional arrays and feed them to a dense layer of 50 units, and then an output layer that has a softmax activation function because it is going to output a probability and an amount of units corresponding to the same amount of categories that there are in the dataset. So basically the output of the model is not a category, but it's instead a probability distribution, and we can get which class corresponds to the given image by checking the argmax function from NumPy. So basically, here we get a 94% accuracy, which is really good, and a loss of 0.3184. So basically what we can see is that the model is relatively accurate and the accuracy is very similar to the training accuracy, which shows that the model is not overfitting. And with that, I conclude my demonstration. Thank you very much.